Hey, it's Angela here. Congratulations on making it through the first 10 days. Today, I've got something very special lined up for you. Our first capstone project. Today, we'll challenge you to apply everything you've learned so far into one big project. You're going to need to dig deep and apply all your Python skills for this capstone project. But by the end of the day, you'll have built an awesome blackjack game to enjoy. This is probably going to be one of the hardest things you'll build yet, but at the same time, the end result is also going to be the most fun. The final project you're going to be building is Blackjack. And if you head over to 247blackjack.com or search for any other free online blackjack game, you can hit play and you can click deal for the dealer to give you some cards. The game is really simple. Essentially, you're trying to get as close to 21 as possible. And all of the cards which have a jack, a queen, or a king count as 10. So you're adding these two cards up. 5 plus 10 equals 15. And you're trying to figure out if you can risk getting another card. So I'm going to click hit. And I'm going to get one other card. But that takes me over 21. And so the dealer wins. So this is the game that we're trying to create. This is what your version of Blackjack is going to look like. Now, the user interface is a little bit simpler, but it's just as fun to play with. So our first two cards are a 9 and a 10. And it also shows us one of the computer's cards. Now, I'm already on 19, 10 plus 9. I'm close to going over 21. So I'm going to type N and end the game right there. I end on 19, the computer ends on 18, and because 19 is greater than 18, that means I win. Have a go at playing the final game by going to blackjackfinal.apiary.repl.run, but once you're ready, head over to the next lesson so that we can actually build this game ourselves. For all of that and more, I'll see you on the next lesson. Have fun. Alright, let's talk about the mechanics and the program requirements for the blackjack game that you'll create. For those of you who are not familiar with the game of blackjack, also known as 21, I'm just going to spend a few minutes to go through the rules with you. Blackjack is a game that's played using cards. And the goal of the game is to add up your cards to the largest number without going over 21. If the cards in your hand add up to more than 21, then it's called a bust, and it means that you lose immediately. And it doesn't matter how much you've gone over 21. As long as it's over 21, then you lose. Now, the way that the cards are counted is that all the cards from 2 to 10 count as their face value. So a 6 is a 6, a 9 is a 9, etc. But the jack, queen, and king each count as 10. And the other special card is the ace. Now, the ace can either count as a 1 towards your total, or it can count as an 11. And depending on whether if you've gone over 21 or whether if you're under 21, you can decide which value you want your ace to represent. Let's play a sample game. Let's say that the dealer over here got a 10 to begin with, and you got a queen, which also counts as a 10 to begin with. So these are the first cards that are dealt, and both of these cards are revealed. And then the dealer deals another card to each of you. Now, the dealer's second hand is concealed, so you can't work out what their total is. But you can see your own card. So at the moment, we don't know what the dealer has. It might be 10 plus anything. But we know that our score is 13, 10 plus 3. At this point, you might ask the dealer for another card. So now you have 3 cards, and luckily it adds up to 20 without going over 21. But there is also a possibility that you might have gotten a card that would have pushed your total over 21, at which point you now lose. And it doesn't matter what the dealer has in their hand, you've already lost because you've gone over 21. Now let's say that we got lucky and our total adds up to 20. Now at this point we say we don't want any more cards and the dealer reveals their hand. If, like in this case, they end up with 20 and we have 20, then we end up in a draw. So whenever your score equals the dealer's score, then you will draw rather than win or lose. Now, if on the other hand, the dealer ended up with an ace, which we know can count as an 11, and they actually scored higher than us, they have 21 and we have 20, well, in this case, we would lose. Now, the rules also state that if the dealer ends up with a hand that's smaller than 17, so 16 or under, then they must take another card. Those are the basic rules of Blackjack. But I recommend that before you get started, head over to the link that's in the Blackjack starting file and have a few games of Blackjack, just so that you can see for yourself how it actually works and how you win and how you lose. And then head over to the final version of the completed project and play our simplified version of Blackjack. This way, you'll see what the end result is that you're trying to create, and it will be easier when you're creating the code yourself. Now, as I mentioned, we're going to try and keep our version of Blackjack a little bit simpler, and we're going to assume a couple of things. The first thing is that the cards that we're starting with comes from this list. You'll notice that I've got 2 through to 10 all represented in the list. And then I've got Jack, Queen, and King represented as 10s as well. So this means that the 10 has 4 times the probability of occurring compared to the other cards. Now the ace is going to start off being represented as 11, and it's going to count as 11 until the user goes over 21. Now finally, we're going to assume that we have an infinite deck. So it means that when a card is drawn from the deck, it's not removed from the deck. Whereas in a real casino, they have maybe 6 or 8 decks of cards. When a card is drawn, then there's less probability of that same card occurring again. And this is how professional card counters, the people that the casinos hate the most, actually go about trying to optimize and improve their chances. But in order to keep things simple in our game, we're not going to deal with things regarding probability or removing cards from the deck. We're going to assume that each of these cards in the list have equal chance of occurring. If you head over to the @Brewery Blackjack starting project, you'll see each of these rules written out in more detail. Take a look at it so that you're aware what our house rules dictate. Now, if you scroll to the very top of the Blackjack project, I've given you 4 tracks. So just as when you start a video game, you have the choice of normal, hard, extra hard, or expert, it's the same in this project. You can limit yourself to using only 1 hint if you are at expert level in Python. You can only use hint 1 and 2 if you want an extra hard challenge and maybe a little bit of a cry at the end. There's also hard and normal. So I'll leave the choice up to you. And if you scroll down, you'll find all the hints listed in here. Now, I recommend everybody, no matter your experience, everybody should try out the Blackjack game and also look at how the final project is supposed to work. But then I've got other things such as a list where I've broken down the program requirements. You know how we always say when you have a big problem, always try to break it down into smaller pieces. Now you can, of course, create this list yourself by exploring the game, exploring the final project, and then writing your own to-do list of things that need to be coded up. Or alternatively, you can look at the one that I've created inside Hint 2. Inside Hint 3, I've created a flowchart for you, which takes the to-do list and breaks it down into a flowchart where you can look at the logic in more detail. Now, of course, as always, it's a good idea to create your own flowchart using a tool like draw.io or using a piece of pen and paper. But if you need help, it's there for you, and you can download the PDF and read through it. Now, the rest of the hints will go through how to solve this project in even smaller bite-sized chunks. Depending on your own level of Python at the moment, choose your own difficulty level. But I just want to say before you get started that this project is difficult, and I wanted to give you a bit of a challenge and to push yourself so that you get stronger. But there will inevitably be moments where you will have doubt and you will be wondering, what am I doing? I don't understand anything. And in this moment, I want you to look yourself in the mirror and tell yourself that you got this, you can do it. And that remember that I'm here rooting for you. I believe you can do it. You've got everything that you've learned so far will enable you to do it. There's nothing new in this challenge. You just have to put all the pieces together. You have to push through the difficult parts and maybe sleep on a problem and think about it and then come back to it. But I believe you can do it. Once you're ready, pause the video, head over to the starting project and give it a go. And once you're satisfied, then head over to the next lesson and I'll walk through the solution with you. All right, so how did that go? I hope it went really well and you've managed to complete it all by yourself. If you got stuck, I really recommend just having a sandwich, have a cup of tea, take a break, and then come back to it. You'd be surprised what your brain can do when it just has a little bit of rest. But I want you to make sure that you've really given it a proper go before you come here and watch the solution. Because I'm going to walk you through the solution step by step in case there are little bits or something that you didn't understand or something that you want to check. But I really, really hope that you've managed to tackle most of this yourself. All right, so without further ado, let's get started coding up our Blackjack project. Hopefully you've already used hints 1, 2, or 3. And I'm going to get started with hint 4 and build up our Blackjack project step by step. Now, the idea of the hint 1, 2, and 3 is to get you to create these small to-dos of your own so that you can have practice breaking down the problem into a list and then breaking it down into a flowchart and then breaking it down into smaller bite-sized to-dos. So let's start out with the first one. We have to create a deal card function that uses the list below to return a random card. And 11 is going to be the ace in this deck. So let's get started by forking a copy of this REPL, and we're going to go and create our deal card function. Now, this function is going to contain these cards. So I'm going to go ahead and paste it in, make sure it's indented so it's inside the function. And now I'm going to use these cards to randomly pick one out of this list. So to do that, we can of course import our random module. And then I'm going to use random.choice to pick a random card from my list of cards. And then this of course has an output, this random.choice. So I'm going to save that output, namely the random card, inside another variable called card. And then finally, we're going to return this chosen card as the output. So that's step 4 done. Now let's move on to step 5. So we're going to deal the user and computer 2 cards each using the deal card function. And very helpfully, the hint tells us that we can start out with a blank user card and a blank computer card list. So we basically just have to add 2 cards to each of these lists. To do this, I'm going to use a for loop, and I'm going to use the range operator to run this for loop twice. So you've seen this syntax before when we talked about for loops, and I've got an underscore here because we don't actually need this particular variable. All we need is for this loop to run twice, and this code is going to achieve that. Every single time this loop runs, we're going to get a new card by calling deal card. Now remember that deal card has an output. It outputs a random card. So if you want, it's actually quite helpful to add some documentation to this. So we could say returns a random card from the deck. And now when I write deal card, you can see that the doc tells me that this function is going to return a random card from the deck. So that random card is going to replace this function call, so we can capture that data by storing it inside a variable. So we'll call that new card and set it equal to the output from the function deal card. Now, the next thing we're going to do is we're going to add this new card to the user's cards. So at the moment it's an empty list, and all we have to do is say user cards dot append, and then the object that we want to add to that list is going to be the new card. Now, some of you might be tempted to instead use the plus equals. You might want to write something like this: user cards plus equal new card. And I want to show you what actually happens when you run this, because this is a really common error. We get a traceback and we get a type error. It tells us that the int object is not iterable, and it highlights this line 49 as the reason for the error. So what's going on here? Well, this plus equals is actually shorthand for writing the extend function. Now you can see that the extend function is something that extends a list by appending elements from the iterable. So what does this mean? Well, it means that whatever you put inside this parentheses, it has to be a list itself. For example, if this new card was a list of cards, so maybe just the first dealt card and another card, or even just it by itself inside a set of square brackets, which turns it into a list, well then if we run this code right now, we no longer have any errors. And if I convert this back to what you saw before, which is using the plus equals, we also have no errors. But when you only want to add a single item, not a list, to an existing list, then you have to use append. So hopefully you didn't have this issue, but if you did, this is the reason. Now that we've created these two lines, you can see that it's a little bit redundant because we're creating this new card variable just to hold the output from this function. And then we're immediately putting it into this list using the append. So instead, we can actually just get rid of the middleman and put deal card directly inside the append. And this does exactly the same thing in a single line of code. Once we've done this for user cards, we'd probably want to do the same thing for the computer's cards. So computer cards dot append, and then we call deal card again, remembering the parentheses. So we've got a total of 3 parentheses at the end. And this way, we deal a new card, and that new card gets appended to the end of this list. All right, so now let's tackle hint number 6. We're going to create a function called calculate score that's going to take a list of cards as an input, and then it returns the score after calculation. And it tells us that if we get stuck, we can look up the sum function to help us. So let's create a function called calculate score. And this calculate score is going to take some cards as an input. And then inside the body, it's going to calculate the total of all the cards in this list. So if we take a look at the sum function in Python, the way that it works is you can put a iterable, so like a list, inside the parentheses as an input, and then it's going to add up all of the items in the list, and it's going to return the total. Back in our code, we can simply write sum, and then inside these parentheses, we can pass over the cards, and we can return this value as the output. Basically, if we had cards equal to a list with 1, 5, 3, 4, then this sum function is going to end up being equal to 1 plus 5 plus 3 plus 4, which is going to be equal to 13. And then that will become the output of this function. So now let's move on to hint 7. A blackjack only happens when we have a hand with only 2 cards. And those cards have to be an ace and a 10 value card. In our deck, we know that an ace is represented by 11, and we have a number of 10 value cards. So there's a number of ways that we can check for this blackjack. One of the ways is by checking to see if the 11 is in our deck of cards. And then we can combine that with an and to check if the 10 is also in our deck of cards. And finally, we can check to make sure that we've got a hand size of 2. So we can check that the length of our cards is equal to 2. And this would represent this logic. A hand with only 2 cards, an ace, which is represented by 11, and a 10. Now, on the other hand, we could actually also simplify this, because a hand with only 2 cards that must contain an 11 and a 10, we can, instead of checking for both 11 and 10, we can check to see if the total, so if we summed the cards, and if this was equal to 21, then it would be exactly the same thing, right? 10 plus 11 is 21, and we've still only got a deck of 2. In this case, what we want to happen is we want to return 0 instead of the actual score. So this way we can indicate that the user or the computer has got a score of blackjack. That's hint number 7 sorted. Let's move on to hint number 8. It tells us that inside calculate score, we should check also for an 11, which is an ace. If the score is already over 21, then we should remove the 11 from the cards and we could replace it with a 1. Because remember that an ace can count as an 11 or a 1. So in the beginning, when the user's score is very small, then we probably want to count it as an 11. But once the user goes over 21, then we probably want to change it and count it as a 1 instead, so they don't go over and they don't lose. Let's first write the if statement. So if there is the 11 inside our deck of cards and the sum of the cards, so the total score, is already over 21, then we want to do something about it. And the hint tells us to look up the append and remove functions. So we've already seen the append function many times, and we know that it just adds a single element to the end of the list. Now, the one that we haven't used a lot of is the remove function. And this will search for the first instance of the given element and removes it out of the list. This is kind of what we need to do. We need to go ahead and remove the 11 from the list of cards. So we can write cards.remove, and inside the parentheses, we use the 11. And then we do cards.append so that we end up adding a 1 instead of the 11. This way, we remove the 11 and replace it with a 1. And hopefully our cards will now take the user to below 21. Now let's move on to hint 9. So we want to call calculate score at some point in our code. And if the computer or the user has a blackjack, or if the user's score is over 21, then the game is going to end. This might be a good time to start tidying up our code a little bit, because we've got our function over here, the calculate score function. And remember that you can only call a function after it's been declared. So for example, if I wanted to call this function over here, then I actually can't. I can't say calculate score because it hasn't yet been declared. So instead, what I'm going to do is I'm going to take this function and I'm going to move it to where we dealt our cards. And I'm going to collapse some of these functions so I can see my hints and my code a little bit easier. So now that I've moved my function to above the line where I want to call it, it's now become valid code. And this is the place where I want to call it because it's only after I've dealt the user and the computer some cards can I actually calculate their scores. Firstly, I want to calculate the score using the user's cards. So this list of cards from the user gets passed into this function and uses all of the logic to output some sort of score. And then I'm going to store that score in a variable, which I'll call user score. And I'm going to do the same thing for the computer. So computer score equals calculate score. And remember, it's always helpful to add a little bit of a docstring to tell ourselves and other programmers what this function does. Let's quickly summarize it. So this function is going to take a list of cards and return the score calculated from the cards. So now when I open that parentheses, I know that I probably have to pass in my list of cards in order to get back the score. So let's put in the computer cards in as the input. And now we've got the user score and the computer score. So this score could equal 0 if they got a blackjack, or it could just simply be the value of the cards that they hold all added up together. Now that we've called calculate score, we also want to make sure that if the computer or the user has a blackjack, or if the user score is over 21, then we have to end the game. Let's write our if statements. If the user score is equal to 0, or the computer score is equal to 0, or the user score is greater than 21, then in this case, we're going to tell the game to end. So we could create a new variable called isGameOver, and we start out with false, of course, but then when this happens, we're going to change that variable to true instead. Our isGameOver variable is just a simple Boolean. It starts out as false, and when certain conditions are met, then we change it to true. Now at the moment, our program is not finished, so it's not really obvious how we're going to be using this isGameOver variable. But we're setting ourselves up for the next steps. Now that we're tracking if the game should end, we can look at this value to determine what to do next. So that's hint 9 completed. Let's test our code and see how everything works so far. I'm going to add some print statements here so that I can see what the user's cards are and what the user's score is. Using an F string, I'm going to show your cards, so the user's cards, and the current score. And I'm also going to print the computer's first card. Remember when I first explained the rules of Blackjack, the dealer will reveal their first card. So you get a little bit of a clue as to what kind of hand they might have. So in here, we're going to insert the computer's cards, and we're only going to pick out the first item. So the one at index 0, and we do that using a square bracket after the name of the list. Now let's give our program a run and see if it actually works. The first thing that prints is a list of our cards. So in our hand, we have a 2 and we have a 6, and 2 plus 6 added together, of course, makes the score of 8. And then it reveals to us the computer's first card, which is a 10. Now we can be reasonably assured that our code is working. And it's a good idea to regularly test your code so that you don't wait until the end when there are a lot of problems and you don't know which part of the code is responsible. Now let's move on to hint number 10. It says that if the game is not ended, ask the user if they want to draw another card. If yes, then use the deal card function to add another card to the user's card list. If no, then the game has again ended. Over here, in the if statement, we can add an else, because if the game hasn't ended, as in they haven't gone over 21 or nobody's got a blackjack, then we're going to ask the user if they want to get another card. I'm going to use a input, and I'm going to ask the user to type Y to get another card, otherwise type N to pass. And I'm going to save this input inside a variable, which I'll call user should deal. Now we can check to see if this variable is equal to Y. Well, in that case, we're going to add another card to the user's card list by doing the same thing that we did in the beginning, where we dealt 2 cards to each player, by saying usercards.append, and inside the parentheses, the thing that we want to append is the output from deal card. So just a quick check to make sure you've got all the parentheses there, and then we're ready to address the else. If they didn't type Y, then that means they don't want another card. Well, then in this case, the game has again ended. So we can say isGameOver equals true. Let's test this out as well. We got 7 and 11 with a current score of 18. If we type Y, hopefully we'll get another card. And we did see that prompt and we saw something happen, but our program then promptly ended. Let's take a look at the next step. How can we get our game to repeat itself? So hint number 11 tells us that the score will need to be rechecked with every new card drawn, and the checks in hint 9 need to be repeated until the game ends. Notice how we've got this flag, is game over, which is set to true whenever the game ends. It starts off being false, and what this means is we can actually create a while loop, which basically keeps on calculating the user's score and the computer score, makes all of these checks, which are in hint 9, and then repeats itself until the game ends. Let's go ahead and do that. After all the initial setup, we're going to create a while loop. And the while loop is going to be active until the game is over. So we can say while not is game over, then go ahead and carry out all of these instructions. So calculate the user score, calculate the computer score, check that nobody's gone over 21 and nobody's gotten a blackjack. And if the user wants more cards, then they should. If they don't, then the game is over. So let's run this and try it again. Our cards are 10 and 10, which probably means we shouldn't get another card because we're already so close to 21. But I'm going to be daring and press Y anyways. And it tells us that our cards are now 10, 10 plus 2. So we got an extra card and that takes us our score to 22. That worked perfectly. So now let's go back and tackle the next part. Hint number 12 says once the user is done, it's time to let the computer play. The computer should keep drawing cards as long as it has a score less than 17. So the while loop is responsible for dealing with when the user wants to keep drawing cards. But once that's done, then we can tackle hint number 12, which is how does the computer actually play? What is its strategy? Well, we know that the computer has to keep drawing cards as long as it has a score of less than 17. But of course, 0, which represents a blackjack, is also less than 17, but we don't want it to draw a card if it has a blackjack. We can represent this logic using a while loop. While the computer score is not equal to 0 and the computer score is less than 17, then in this case, we want to keep drawing cards. We're going to take the computer's cards and we're going to use the append to add a card by dealing another card to the computer. And then we're going to recalculate the computer score so that it updates and this while loop is evaluated on the latest score. So the computer score is going to equal calculate score using the computer's cards. And that means that the updated computer score is equal to the return value from calculate score. So that's hint 12 complete. In the next step, we're going to start comparing our player's hand with the dealer's hand. See you in the next lesson. At this point, we've created 2 while loops. The first while loop is for the user so that they can continue taking cards, and the second while loop is for the computer so that the dealer can follow their strategy. Now it's time to tackle hint 13, where we create a function called compare. We pass in the final user score and computer score, and then we compare the scores to see who has won, who has lost, or if they have a draw. So remember that in order to call a function, it has to be declared before the line we want to use it. So let's go back up, and after hint number 6, where we had the last function, let's add this hint here and create our compare function here. This compare function is going to take the user score and also the computer score, and it's going to compare these 2 scores. If the user score is equal to the computer score, then we said this should mean that it's a draw. So we'll return some sort of message that represents this. But elif, or else if, the computer has a blackjack, so the computer score is equal to 0, well, in this case, we should return that the user is lost and the opponent has a blackjack. And then we go through this list and we add in all of these other conditions. So I'm going to speed it up a bit. Now for the final condition, it says that the player with the higher score should win. So we can write an elif that compares the user score against the computer score. And we're basically saying if the user score is greater than the computer score, well, then that means that the user wins. But if that's not true, and because we've covered everything else, we now have the final return, which is you lose. Now, remember that if, elif, else statements are evaluated from top to bottom. Even though if the computer scores a 0, which is a blackjack, which is obviously much less than whatever score the user might have, because it's going to return at this point and it's going to exit the function, it will never get to this comparison if this is already true. If you get confused about how if, elif, and else works, especially the order in which you add the conditions, have a look back at the lesson where we talked about this in more detail. This might be a good time to revise that concept. But now that we've completed our compare function, we're going to use it at the end of our code here, because this is the time that the user is done drawing cards, the computer is done drawing cards, and now we can call that compare function and pass in the user score and also the computer score. So this should hopefully give us the final result as a piece of text. Let's run the code as it is and see what happens. We started out with a 3 and a 6, making a 9. Now we know the computer's at least got a 10, so let's add another card. So now we have a score of 11 with 3, 6, and 2, so we can still keep going. And luckily we've managed to get a total of 21. Now we're pretty much invincible, I think. So if I go ahead and hit no, because I don't want to take any more cards, then let's see what the result is. So it tells us we win, and a big smiley face. So we could probably give the user a little bit more information, like revealing the final deck, what the computer got and what we got. I'm going to go ahead and create some other print statements above this one. Maybe I'll tell the user that your final hand is this, and the final score was... And then let's reveal to them the computer's score. And then finally, we can print the user score and the computer score to tell them who won, who lost, or whether if it's a draw. In this deck, we've got 14, so let's add another card to it. Unfortunately, we went over because we got another 10. So our final hand is 10 for 10, and the final score was 24. The computer's final hand was 21, lucky them. So we went over and we lost. If we wanted to play another game, because we are blackjack addicts, then we want to give the user some sort of means of doing this, right? And that's what the last hint addresses. So we're going to ask the user if they want to restart the game. If the answer is yes, then we're going to clear the console and start a new game of blackjack, and also show the logo from art.py while we're at it. Let's go ahead and add a input, and we can ask them, do you want to play a game of blackjack? Type yes or no. So remember that this entire function is going to be evaluated, and the result or the output is going to replace this part of the code. So we can say that while the input is equal to y, then we're going to keep playing the game. The game is all the code between hint 5 and the end where we compare. So if we actually put this inside a function by indenting it over and then creating a function here called play game, well then we can actually call this function play game every time the user types y. Now, we don't want to clutter up our screen with all the previous games, so before we call play game, we also want to clear the console. And to do that, we obviously have to import the clear function from the replit module. So from replit import clear, And now we can call this clear function to clear the console in here after each game. And then we can call play game so that the code in this function gets repeated. And we also said that at the beginning, when we play game, we're going to show the user the logo from art.py. So let's go back and import that as well. So from art, import logo. And then at the beginning of every game, we're going to print our logo. That's all there is to this project. And now let's run it one final time and see the whole thing in action. Do you want to play a game of Blackjack? Yes. And it reveals our beautiful Blackjack logo. It tells us the cards that we have. So current score of 11. I'm going to take another card. I'm on 21, which is perfect. So I'm going to pass now. And it tells me that my final hand was 21. The computer's final hand was 17. And I win. And now I can play another game just by typing Y again. And I can keep going on and on playing my game of Blackjack. So I hope you had fun building this game with me. I know this was a really difficult project, and I know that some of you would have probably had some issues, but I really hope that you persevered and you got through it in the end. And through the process, you've managed to apply a lot of the things that we've learned in the last 10 days. This is a good time to review the concepts you've learned and have a think about what you might need to revise or revisit so that you're really, really strong on all the concepts and you're comfortable to continue on to the next 10 days. Now, if you want to take a look at the final code that I've got here, then just head over to replit/appary/blackjack final and you'll see all the code that I went through with you just now. Hey, well done for completing your very first Capstone project. Now, I know it was a difficult project, but it's meant to stretch you just enough so that you're still struggling, but you still have all the components that you need to tackle it. Now, in this project, we saw a lot of the things that we learned in the previous days being put into use, like while loops, for loops, functions, variables, everything all packaged together. Now, these are the fundamentals that you're learning in each of the days and each of the lessons, even though individually they seem very small. But when put together, you can create really interesting and really complex projects like the Blackjack project. So even though it was difficult and even though you had to stretch yourself, as long as you've got solid foundations, then you can continue and you'll be able to build even better things. So together, we're going to make sure that you have a really solid foundation before you continue, before we start building more fun projects like websites and data mining and data scraping and data visualization and all of that. So make sure that you review all the concepts that you've learned so far. And if there's anything that's not quite 100%, then just review the content, practice it a few times, and then continue, and you'll be so much better off for that solid foundation. So have a good rest, and I'll see you tomorrow.